Alright, you guys, here we go. So yesterday we discussed how to use summation notation. Just as a reminder, can you guys remind me, how do we read something like this? The sum of 2 to the j from j equals 3 to 6. Okay? What is this 2 to the j called? That's called the what? Argument of the summation. What is the j called? The index. It's called the index. Okay? And we move, the j goes up by what kind of values? Integers only. Okay. Alright, we're going to pause until everybody calms down. Santiago, that was not your seat. Where's your seat? Can you go please to your seat? And then one of you guys can sit over there. Unless you prefer to sit here. He's absent. He's not doing, he's ill. Santiago, I'd like you to go faster because you're wasting the entire class's time. Okay, I want you guys to look at number 32. Waylon wrote this expansion and he did something wrong. I want you guys to quietly think about what he did wrong here. Raise your hand if you have an idea of what he did wrong. Okay. Alright. Chante?
It's because he's going through by decimals.
He's growing by decimals. Can we do that?
No.
No, we have to grow by what?
Integers.
Integers only. Okay, Abraham, I want you to pay attention and put the marker down. Okay, here it says explain to your neighbor what the sigma notation means. We're going to skip that, but you do need to know what the sigma note. Actually, let's go ahead. Well, at the end, we're going to add this to our learning log, okay? So we'll do that later. Okay, so who can read for me this little blurb right here while everybody actively follows along and actively reads? Okay, who is that? Oh, I just called on you. Jennifer?
Sums that do not increment by one.
Increment.
Increment by one, such as one. Waylon tried in problem 232 are going to be important later in the chapter. The next few problems will develop a method for writing sigma notation to add up sums like these that do not change by 1 unit each time.
So it's saying that, you know what, we can have sums that don't grow by 1. We can have sums that go 0.2, 0.3, 3.5, or sorry, 3, 3.5, 4, 4.5, 6. We can do that. We're going to talk about that in a little bit. By the way, you guys, here's a vocabulary word, and I'm just throwing it at you. Write it down somewhere where you think it's important. A series, okay, a sequence is just a list of numbers in a particular order, a sequence. Right? A sequence is a list of numbers in a particular order. A series is the sum of a sequence. A series, what is a series? A series is when you have a sequence of numbers and you add them all up. That's what a series is. So like this is a series. And we can use sigma notation to talk about the series. Does that make sense? The sigma notation is a shortcut, okay, for us to add up or to notate a series. This is a series because it's a sum of a sequence of numbers.
And the sequence is just a list of numbers?
A sequence is a list of numbers. A series is a sum of the list of numbers. Sigma notation helps us denote a series.
So all of those numbers that like you write out, that's a sequence, and the sigma notation is the sum of the series?
The sequence here would be this, this, this. That's a sequence. And I could say it like this. That's a sequence. When you add it up, that's called a series. Okay? So in calculus, there's a topic called sequences and series. Actually, that's a pre-calculus topic, which we're doing right now, sequences and series. Okay? All right. Okay, in your notebooks, okay? Did you guys start this in your notebooks? No. So I want you to go to your notebooks, and so we should have this in our notebooks. Shh, quiet. Summation and sigma notation, right?
Yeah.
Yeah, the next blank page. So let's start with number 34.
Yeah.
Okay? I hope you have graph paper. Your notebook should have graph paper. It says find a rule for a linear function f such that f of 1 equals 2.2. I'm just reading from the packet here. And f of 5 equals 3. Write the function in point slope form and slope intercept form. Can you guys graph this first? Okay, so you guys get me? Did you guys follow along? You already wrote this down? Yes? Okay, Abraham, put the marker out of your hand. Write this down in your notebook, please. Is everybody caught up?
No.
Okay, so basically you're gonna do this problem. I'm gonna give you guys 2 minutes to do this in your groups. But here I want you to also graph. Okay? So first start with a graph, okay? Start with a graph. Now, if I'm gonna start with a graph, how can I graph? What does this really mean?
Plug in 1, you get.
You plug in 1 and you get 2.2. So which one's the x value? And which one's the y value? So can I make a little table? So I have 1, 2.2, that's my point. What's another point? No, when you input 5, you get
3.
So can you graph that and then make a line and then give me that equation of that line in both point slope form and slope intercept form? Okay? Okay, so do that. You have 2 minutes with your groups. Yeah, graph those 2 points, make a line, and give me the equation of that line. 2 minutes.
Do I really need to graph it to give you equation of 1?
You don't need to, but I want you guys to see the picture.
Do I have to? Is that we all can do it?
Okay, you have a minute and a half now. Thank you, Jennifer. Thank you, dear. Okay, you have 1 minute. give you 15 more seconds. Yes. This should be second nature by now because we did it in Algebra 1 and we did it in Chapter 1 of this. Actually, I didn't do it in my Calm down. All right, you guys, let's talk about this. All right, can everybody look up here, please? Okay, hopefully this was something that was pretty easy for you. If you were to graph it, you see, hey, look, this is 2 points. The input is 1, the output is 2.2. When I input 5, the output is 3. Now, how do I know that I should connect the dots with a straight line and not something squiggly or parabolic? Because it told me that this is a linear function. Okay, so I could make a straight line. Now, what is the equation? Yes?
What if it doesn't tell you?
If it doesn't tell you that, we cannot assume it's connected by a straight line. There's a myriad of things that could be happening in between there, right? So how do I find the equation of a line? I could either do y equals mx plus b or the point slope form. Which one's easier in this case? No, because then... Huh?
Wait, what if you found both?
You have to find both, but which one's easier to start with? Point slope, because otherwise I have to calculate my y-intercept, and I don't know my y-intercept. So point slope says, first of all, for point slope, I need a point. Do I have a point? Yes, I have 2. And I need a slope. Do I have a slope? To find the slope, I can do y minus y over x minus x, right? Which is 3 minus 2.2 over 5 minus 1. So that's 0.8 over 4, which is 0.2. So that's my slope. That means every time I go over 1, I'm growing by 0.2, 0.2, 0.2, 0.2, right? Okay, so I have y minus something equals 0.2 times x minus something. What should I put in there? I could do this one and this one, or I could do that one and that one. Which one you guys like better? The 5 and the 3. So there's my equation. If you did the other one, that's fine too. So this is called point slope form. The other one is slope intercept. How do I get it from point slope to slope intercept? Distribute. Yes, thank you. Thank you. Okay. What's 5 times 0.2? Nice. Okay. So now we know that the slope. So what is the y-intercept? What's the b? 2. So if this line kept going, it should cross through the y-axis at 2. Okay? That was just a nice little review. Okay, that's not what this chapter is about. Okay? But are you guys clear on this? Why are we making these noises? Okay. All right. Are you guys any questions on this? Okay. So let's turn to the next page. But the next page is a little kooky. So let's go to the last page in the packet that I reprinted for you. Okay, look at the last page. Okay, we have to move a little faster, guys. Come on. Does everybody have this? Raise your hand if you do not know where this is. Okay, everybody knows. All right. Now, there is a reason that I had you guys graph this, okay? Actually, I want you guys to think about these points. What is the y value at when x equals 1? 2.2. So when x equals 2, what is the y value?
2.4.
How come?
Because it has
The slope is
0.2.
0.2. So every time I go over 1, how much should I rise? Do you agree that when you rise 1, you go up 0.2? Yeah? So what is the y here? 2.6, 2.8, and then 3. You get me? All right. Did everybody get that? Okay, with that in mind, and you guys see where we got that. All you have to do is every time you grow, it grows by what? What's my grow by number? 0.2. So now, keeping that in mind, can you use the result of the previous problem to express this in sigma notation? So remember, in sigma notation, my integers here, from here, my index has to be a whole number. It has to be an integer. Not a whole number. It has to be an integer. So how can I express this?
2.
Okay, I want you have 1 minute to discuss with your group what you think that should be. Okay, I want you to focus and not be talking about silly things, Abraham's group.
You would have to add by 1. No, you would have to add by 1. There's no slope. Start at
It's at the end, the last page.
Don't tell me I'm not sure. How am I going to be sure, Snap?
Did you guys get it?
No, I just said okay.
Yes, you do. It's at the very last. Oh, unless it got cut off. You might have lost it. Just look at your partner. All right. Okay, so who can tell us what you guys got? The summation of what? I see one hand. What? Okay, Jesus, tell me. 2? 2 different ones? No, you came up with, just write 2? Okay, 2. Oh, so that's the answer? So 2, the sum of 2 equals that?
0.2.
0.2?
Yes, because it's going by 0.2 as it goes
So
after
you do
K equals 2.
0.2K plus 2.
0.2K plus 2?
No. K plus 0.2.
Wait, what's wrong with this?
K plus 0.2.
It's K plus 0.2, miss.
Not
Wrong
2K.
with this. Not 2 people, miss. These people.
Oh, it does work.
This works, doesn't it? What is my first index going to be?
1.
And then how up to what? Y. 1, 2, 3, 4, 5. Okay, wait, let's think about that. Okay, if I were to plug in 1, then what am I going to get? 2.2 plus 2, so I'm going to get 2.2. If I plug in 2, what am I going to get? 2 plus 2.4, so it's going to be 2.4. Hey, it works!
Wait, what?
And then if I plug in 5, it's going to be 3, right?
I don't understand.
No? Okay, so let k equal 1. Then 2 times 1 is 0.2.
Wait, what?
This is 0.2. 1 times 0.2 is 0.2 plus 2 is 2.2.
Right now, do 2.
And then 2 times 0.2 is 0.4, right? Plus 2 is 2.4. Okay? All right, you guys. This is called a linear series. A linear series. Why is it called linear? And it's growing each time you're growing by something that you're just growing by 0.2 every time. So it's linear. If I was growing by an exponent or something, that'd be different. If it was an exponential group, that'd be different.
So the sigma notations also like depend like if it's like apparent equations, like for example.
Yeah, we can do that. Yeah, we could talk about that. But we focus at first. Today we're gonna just focus on linear. Okay, hold on. There's so much commotion. I'm pretty sure that I asked Richard to find another seat. Okay, so do you guys see how we got around the fact that, look, the index is still integers, but we were able to add decimal increments using this little trick. You see how we did that? Did anybody else have a different summation? Because this is not the only way. Did any group? Okay, Christian. K over 5 plus 2. That's true. You know why? Because 1/5 is 0.2. Right? Did anybody else, like Jennifer, did you guys have something different?
No, they just denied mine.
Was anybody have anything different? Okay, very good. All right. Now, use the following. Okay, let me ask you this. Could we do it where we start at?
Start with the sums.
Never mind. Okay, use the following sum, or we can call this a series, right? To answer the question below. Questions below. So now this is our new one, okay? Can you express this? Remember, you're writing this in your notebooks, right? Not on the paper, right?
We write the question?
You don't have to write the questions, but you're always showing your work in your notebook, okay? So, you know what? We're gonna...
That got cut off, miss. So do we just look at your...
What got cut off?
That, like A and B?
No, it didn't.
Wait, what is that? Oh, it's 36.
Okay, you guys, I'm gonna give you guys 10 minutes. 10 minutes to do 36 and 37, okay? In your groups. Then work together. Ask your group.
Isn't there some kind of way just like where you like subtract the biggest number minus the smallest?
Yeah, but that's different. We did it, so we can talk about later. But I thought you were trying to make this connection. There's
This one was it has to be.
Okay, you guys, for this one, maybe, just maybe, it might be easier if you start at, instead of 1, where's another place we can start? Let's start at 0. You don't have to. You can start at 1 still if you want, but what if we started at 0? Okay? No, there could be a formula. It's still linear, right? It's still linear. It's still linear, so it's still growing by something. It still has a starting point. Right? What is the starting point?
One would be here, and 2 would be 0.8 plus 3. 3 words enough?
'Cause it has a grow by number. Damien, focus, okay?
We missed. I think we got one. I'm not
Good.
sure it works.
No, that's right. You got it. I can see it.
You can see it.
Now try the next one. Good job.
Oh yeah? Alright, the next one. I can't even read that.
Oh, I see. Okay.
Sure.
What did you subtract?
That's not funny. Shut up.
Okay, you're doing 36 and 37.
You're doing B. I did A. Where's the group work? I'm writing too.
It's going by 0.8? Oh, yeah? So if it's going by 0.4,
I mean, okay, I didn't say anything. I didn't say you're wrong. That's a good observation.
Yes. But then where do we start?
Then we will start at 1.
Yeah.
What is so
But then where does the K start?
Oh, okay.
It's this one right here. But well, she said this the top number would be 6.
Yep.
And we'll start at 1.
Yep.
That's it?
Yep.
Just asking like what yeah, if you keep
You're right.
but I know
We're halfway there.
You just said
and then you just add
Put it away.
Okay, you guys, let's stop for a second. Oh, you also you want to keep going? Okay.
Like it said, everybody looks like 0.
By looking it. That's what I said. But he said, well, sometimes it's complicated.
it'll be 4x plus 2.
I mean, if I put the right version. But so I'm starting with the intuitive, but then later on when it gets complicated, I love the level of engagement today, you guys.
Say tough. Tough.
That's a little different, but it's
To,
making it probably a few words.
say that. No, I think I say to and the.
Okay, so where's your next start then?
To. See?
Good job, guys. Good job. Very nice.
See? It comes out naturally. To the.
Own it. Say, I'm a girl.
Don't say it fast. I'm going to. Say it fast, don't You do, obviously. When you wrote it, then I'm like, I talk like that. I guess.
But don't do that in an essay.
I don't know how to explain it. That's what you get. Comment. I don't know how to explain it.
All right. Okay, we're gonna stop here. All right. Sorry, we're gonna stop. Okay? We have 40 seconds left. Okay, so I think a lot of you guys have come to the conclusion that you guys, by the way, I'm loving the engagement. I see every single person working and thinking and talking to each other. That's great. So if K starts at 0, what are we gonna have? Jesus, tell me. No, it's my timer. What is it, Jesus?
I put a 0.4 x or k.
Oh, sorry, K, yeah.
Yeah, plus 3.6.
Good. By the way, we're gonna use K's, okay? If you have any X's, get rid of those X's, okay? The reason why, Jesse, is sometimes we have X's somewhere else. Like we might put X at the top, where the top limit is a variable. Okay, so we're gonna save X for something else. For summations, we're gonna use K, all right, or J. If we start at 0, then where should we go up to? Is it 4? 1, 2, 3, 0, 1, 2, 3, 4. Okay. Okay. Do you guys see how this works? Because if I plug in 0, what do I get? 3.6. If I plug in 1, what do I get? 0.4 plus 3.6, so it's 4, okay? Some of you guys said it a little differently. So how did somebody else say it? 0.4x plus 3.2 when you're starting at 1. If you're starting at 1, then for your first one, you have to get all the way up to 3.6. So you have to do 3.2 plus 0.4. So if you're going to start at 1, you're going to have your beginning point has to be 3.2. If you're going to start at 0, then your beginning point is 3.6.
You could also start at 4 and end with 8 by using 0.4.
So in a sense, what you're doing is you're shifting the line, but then you're shifting something else down. So you could start at 2.
But then just subtract the 4 from a 3.2.
If you start at 2, though, I don't know about starting at 2. If you start at 2, then what are you going to plug here?
Wait, does that have to be those exact numbers?
Yeah.
Never mind.
Okay. Hold on. Let's stop. Did every group get either the blue or the red answer? Does every group understand how both of them make sense? Okay. Now, what changes would you make if you wanted to start at 4? Then this one, the K would change from 1 to... Oh, thank you. 1 to 5. And over here, your K would be from... What? It would go from 2 to 6. See that? Does that make sense, y'all? No? You had to change the equations too? That's true, you can change the equation as well. But, you get it? Okay, so if I wanted my notation, instead of starting at 3.6, if I wanted to start at 4, all I have to do is take this one, because if I plug in Z, I would have to just start at 1 instead. So I would say K equals 1 to 5 of 0.4K plus 3.6. Okay, because now if I start at 1, my first entry is going to give me 4. Get that? Okay. All right. No, let's talk about the second one now. Suppose that you want to express this. What makes this different? This one goes all the way to 23.6. But we're beginning at 0. Okay? Can you guys, who can raise their hand and tell me why we want the sum, the argument to be this still? Why is the argument still going to be this? Raise your hand. Jay?
Oh, Jennifer wants to go. No, Jennifer.
Well, because it's moving by 0.4.
Okay, it's growing by 0.4 every time.
And when you plug it in, it's still the same thing.
You still want, when you plug in 0, you still want the first term to be 3.6.
Can I give my explanation?
Okay?
Okay, although this might not make any sense, I tried my hardest.
Okay?
I said, because as k is multiplied by 0, and k increases the sequence, the number will continue to add up according to the function.
Okay.
That makes no sense.
No, I see what you're saying. So every time this increases, you're going to add a 0.4. What is the maximum value of k? So this is going to be starting at 0 and going to what? Well, no, we don't want that to go to 23.6.
It's going to go to
24.
23.6 has a Y.
How do I know what this should be?
Plug it in.
Plug it in where?
Right
You make an
there.
equation equal.
So whatever I want my last one to be. Okay? What should we do, Abraham?
Subtract 3.6.
Basically, the 23.6 has to be 0.4k times the 0.4 times the maximum k plus 3.6. So I subtract that, so 20 equals 0.4k. So k equals,
20. Wait, what?
is it 50?
Yeah, it is.
Oh, yeah.
So if I go from 0 to 50, that's going to end at 23.6. Did you see that? Okay, so can you guys find this one for me then? Okay, do D, guys. Do D for me. Okay, children. Okay, you guys, now do this one. I just did it up there. Good.
So can I go to the bathroom?
No. We only have 5 minutes.
Will it be 0.5 plus 0.5k plus?
Is it growing by 0.5 though? Look at how much it's growing by. Yeah. Yep. Plus what?
2.5.
Yep. And then how far does it go up? Well, not up to 2.5. You have to figure out what's the maximum. So that's the question. Did you finish it, Jay? Okay, well, this is like the exit slip. This is, did you get today's lesson?
I didn't get it.
Okay.
Miss, do we really have to explain what the function is?
Yes. Somebody said it verbally. Jennifer, right?
What would you describe what's the last one again? Like what's the name of that course?
Anything? Because start at once.
What is that bit called? What is the 0.4 called? Like what's the name of
Yeah, that's the slope.
So I could just call it slope?
Slope of the linear. Not today, I guess we can't. Calm down.
So I could just say it's the slope of the line?
The slope of the linear series, or the growth factor. Huh? What about? I already explained it like 3 times. All right, so you guys, what did you guys get? What did you get for the slope? 0.2k plus what, guys? Starting at 0, going all the way to 100. Okay, there's your answer. Maybe I should throw this in the quiz tomorrow as well.
It takes me time to process it.
I might. Be ready. Are you gonna ask me to repeat something I already said? Okay. Depends. Just whatever's in the homework, and yeah. If it was in the homework, yes. Alright, it's based on the homework though. Alright, you guys, pack it up. Pack it up.